Welcome once again to the solutions of All India Akash Test Series. Test 5 Code E and F, and I'm here to discuss the physics. The test date is 3rd February 2019. So let's begin with the question number 1. An electric dipole placed in an electric field generated by point charge, then the net electric force on the dipole must be 0. Net electric force on the dipole may be 0. The torque on the dipole due to the field may be 0. Okay, so we have 4 options. Now, if I discuss this question, then in the first phase I can say electric field due to a point charge is non-uniform. You know very well, because this and this. This is the electric field due to point charge. If I place one electric dipole from minus q to plus q, so dipole moment direction will be negative to positive, right? So I can say there are no any situation such that net force is 0, right? And if dipole is placed along the field lines, then force will pass through the axis of the dipole, hence torque will be 0. So this is my discussion. So on the behalf of that and by this analysis, option number 3rd will be the right choice. The torque on the dipole due to the field may be 0. So let's move on question number 2. In the question number 2, 3 charges Q, Q and capital Q are placed at the corner of right angle triangle as shown in the figure. If the net potential energy of the system is 0, then value of Q. We all know potential energy for two particle system. So we can write K. K means 1 upon 4 pi epsilon naught, and Q1 Q2 upon R 1 2, separation between 1 and 2. As per the question, net potential energy will be 0. So we have, suppose Q is 1, Q is 2 and Q is 3. So I can make first K 1 and 2 yani Q upon A plus K Q A, and separation between these two, if use Pythagoras theorem, then we'll write root 2 times of A. This is. Another one is K Q square by A, and that is equal 0. So I can take K and a small q as a common. So if I take capital Q common in the left hand side, so 1 plus 1 upon root 2 will be there, and that is equal minus q. So when I will calculate, we'll get capital Q minus 2q upon 2 plus root 2. So this is the final value of Q. So my option number 2 will be the right choice. So let's move on question number 3. In the question number 3, a uniform electric field E exists between two parallel plates having opposite charges on each plates. An electron enter in the field between the plates with speed v0 shown in the figure. If length of each plate is L, then angle with which electron deviate from its initial path. You can compare this question just like a projectile motion or horizontal projection. So you know the acceleration is given by force upon mass. In the case of electric field, force will be this and divided by the mass. And if I go for the slope, so you know very well vertical component to the horizontal component. So this two kind of formula I will use. And if I will concentrate on the deviation, then if I go for the velocity in the vertical direction or along y-axis, so I will write here final velocity along y, and that is equal initial velocity along y plus acceleration along y into t. But there is no initial vertical component because particle is moving along x only. So uy will be 0 and acceleration will be e upon m as I discussed, and time means length upon speed, right? So question says length is L and particle is completing total length. So we'll write for the time L upon speed v0. So when I will calculate, the velocity along y-axis will be E L upon mv0. So my prime goal is to find the value of tan theta. So tan theta, as I said, first I need Vy, and that is EL MB naught, and next one is Vx, and according to the problem Vx is V naught, and there is no acceleration along x-axis because electric field is acting only y-axis. So I will write the value of Vx will remain same, means V naught. So I can write theta is equal to tan inverse EL MV naught square. So this is the value of theta. So I can say my option number 2 will be the right choice. So let's move on question number 4. In the question number 4, the field lines corresponding to an electric field is shown in the figure. E denote electric field, V electric potential. And this question I can solve by property of electric line of forces. So I can say the number of field lines per unit normal cross section decide the intensity of electric field, you know very well. And it is always directed from high potential to low potential. So here I can say the electric field at A will be equal to at C, because the concentration of line you can see here. But if I compare with the B, then we'll write EC is greater than EB, because at the point of C lines are more concentrating as compared to B. So I can write, because line of forces always directed from high potential to low potential, so I can write easily VA is greater than V and V is greater than C. So this is our analysis. On behalf of that, I can say the option number 3 will be the right choice. So let's move on question number 5. In the question number 5, two identical ball, each having mass density rho, mass m, charge q, are suspended from a common point by two insulating massless string of equal length. At equilibrium, each string makes an angle theta with the vertical. Now both the balls are immersed in a liquid. At equilibrium, theta remains same. If the mass density of liquid is sigma, then dielectric constant of the liquid will be. So first I will make the diagram. This is theta and this is charge. Suppose this is capital Q, this is capital Q. So I can observe this is electric force and tension will act here, weight will act here. If I resolve the component of the tension, then easily you can find one component is T cos theta at equilibrium, that is equal to weight, equation number 1. Another component will be T sin theta, and that is equal electric force. Electric force you can write K dash. K dash I am using in place of 1 upon 4 pi epsilon naught. K dash q square upon x square. And if I consider x is the separation between these two charges. So this is my relation number 2. If I divide 1 by 2, tt will cancel. I have tan theta. Tan theta is equal to K dash q square upon x square multiplied with weight of the ball. So this is my relation number 1. But as per the demand of the question, at equilibrium each string make angle theta, it's okay. Now both the balls are immersed in a liquid. At equilibrium theta will remain same. This is very important and this is a clue also. If the mass density of liquid is sigma, the dielectric constant of the liquid will be. So if I take the another situation, then we can observe if I immerse this system in a liquid, then there is a one change. There is another force and that is called upthrust force will act. So the new equation will be T cos theta, weight will act in downward, thrust force will act in upward. So this is the upthrust force. And T sin theta will be equal to Fe dash. Why I am using Fe dash? Because this time the value of K dash will be 1 upon 4 pi epsilon naught K. K will be the dielectric constant. So I will write Fe upon K. And this is equation 1 and this is equation 2. Once again, and for your simplicity you can take this is equation number 3 and this is equation number 4. If I divide 4 by third. Once again you will get tan theta. This time tan theta will be Fe upon K and W minus upthrust force. And this is my equation number, because this is 1, 2, 3, and if I say this equation is A and this equation is B, but tan theta will remain same for both cases as per the question. So you can compare left hand side, then right hand side will be equal. So I will write K dash Q square X square W. But in this scenario, first I will put the value of Fe, K dash Q square X square, and dielectric constant K will be here, and W means weight of the ball. So in this case we will take density of the material of the ball. So density of material will be rho, so rho Vg, and upthrust you will take the density of the liquid, so sigma Vg minus this time. So you can see K dash Q square will cancel, X square will cancel, and in place of W, weight of the ball, you will write rho Vg and 1 upon K. You can take V into G as a common, so we'll get rho minus sigma. So Vg will cancel out, so K will be equal to rho upon rho minus sigma. And I would like to suggest you for further NEET exam, if you will get this type of question, then you can memorize this relation. So on behalf of that, I can say option number 2 will be the right choice. Let's move on question number 6.